Let's do this. Final talk. And I promise to be quick, so that you can get back to coffee and talk with each other. As Klaus said, this is something different than using before. I don't think it's that visionary. My goal is just to give you a spark of one aspect of the use of data that I find highly fascinating. And just to give you some context, it was really funny to have this before, because I'm none of this. I'm neither a data scientist nor am I have deal with big data, besides adding some data myself to the world. And I'm really interested in the big strategic philosophical questions. Just to give you context, my name is Johannes. I'm with a small digital consultancy agency, whatever other buzzwords you want to throw into that. Basically what we do, we're a bunch of geeks who are really fascinated by what technology does, or what new technologies emerge, and how they change our behavior, how they influence how we as human beings behave. And one of the areas that we look at is cities, and how technology actually changes and influences how we live in cities, how city life works, and how it's changing. And what we've done for that last year was organizing the Cognitive Cities Conference that looked at especially that topic, and looked at a lot of different aspects of it. And I just want to pick a few examples out of how technology and how certain aspects of data are influencing our city life, or how it gives us new ideas, new perspectives. And the thing that's happening in that area is that, like in all other areas where new stuff is developing, is that we have a lot of new data sources. Come on, it's nap time. So we have new ways to get data. This is just a few of them, but we have a lot more data available. So we have a lot more actually public data available. And this is something that Germany is lagging behind dramatically, but in cities like New York, or in what the US government is doing, and a lot of other countries around the world, a lot more data is becoming publicly available and usable, like through the use of APIs and stuff like that. So we have more public data available. We ourselves are doing a whole lot to add to that data cloud. So I'm guessing that in this room at least 80% of us have a smartphone, and that's how we now experience our cities. We just walk around, hands down, and we will walk around until a long time. I don't really believe in all these Google glasses and HR stuff until it's really becoming usable in everyday life. So we're walking around, we're checking maps, we're tweeting, we're checking in, we're doing communications, we geolocate our photos and stuff like that. So we're adding a lot of data and information about our city life while we're walking through the city. And that's another part that is really interesting. Sensors or sensor technology has become a lot smaller, a lot cheaper, a lot more readily available, so that actually governments and communities are building a lot more sensors into the city surface. And that is another really interesting source of data that we're going to use. And if you just look at these sources of data, then you can already see some very interesting examples emerge of what you can actually use with that, or what you can do with that. And that's what I want to focus on in this short talk, to give you just a taste of what's happening there. There's very simple stuff that you can come up with by just using this sort of data. For example, there's a service that brings together the publicly available data in New York of the health department with Foursquare. And it does nothing else but you log in with your Foursquare account, and whenever you check into a restaurant in New York, that service checks if there is an entry in the publicly available health data from the health department, and then sends you an SMS with you might not want to eat there, because they have like a health violation or something like that. It's just like the mashup of two available data sets that gives the customer, the consumer, a really good benefit. But nevertheless, with a lot of people, for example, in this case, checking with Foursquare, there's a lot of data available where just individual people walking through the city, checking in at places and where they are, and just from that data, from the, I think, 10 million users that Foursquare has, there's a lot of really interesting insight available. And one student group came up with this. That is called LifeHoods, and it's a student project where they took a couple of US cities and looked at all the check-ins that were publicly available on Foursquare for that city. And then they started to do a lot of algorithm-based looking at the data and sorting it and structuring and organizing it and to see what they came up with. And then build a web service out of that. So what you can do now is go to the website, go to, for New York City, for example, and what you get is this. It's a clustering of all the locations where people have checked in, based on like where like a group of people went and then put it together. So for example, we have here like East Village, Lower East Side in Manhattan. And this is one cluster, so people who checked into this place usually went to one of these other places too. So just by people moving through the city and checking in, you can already see very interesting patterns emerge out of that. And people don't think about like what patterns they leave behind, but just by how they behave, we can learn stuff from that. So for example, you can cluster the city in typical, like what they call LifeHoods. That means like people, certain areas where people move around. So these are all like different LifeHoods. I clicked on this one in this example, and I can see what are like the most popular places in that LifeHood. You can see like this is where Foursquare actually is located. This is the Foursquare HQ. This is the NYU School of Business. The Starbucks is very popular around there, and stuff like that. And then I can see what are actually interesting places that are not really available in other LifeHoods that I should go to, so I can actually plan and start getting information for my own moving through the city from the data of the others. Now what I can also do is I can see like people who move throughout that LifeHood, what other LifeHoods are they moving through? So I can, for example, see that people who hang out in the vicinity of the Foursquare HQ also like to hang out in Williamsburg and stuff like that. So I can start to see relations between different LifeHoods. But what I find really interesting is the other stuff they can see and get from the check-ins. So for example, they can tell you in that LifeHood or in that neighborhood, in that quarter, they can tell you that there is the most activity is on Saturdays. So it actually is a place where people go a lot on Saturdays. And not so much on Mondays. People don't, it's not really like that. They can tell you, when is the most when there is the most activity throughout the day. So you can see, is it more a place where people go to work, or is it more a place where people go to have a drink after work, or is it a place for nightlife? Then, based on the categories in Foursquare, they can actually tell you what are the most popular places around there, so they can give you an idea, is that something where people go for food, is it something where people go for entertainment? It is just by using the data of people moving through the city. It's just an example of the data source that we actually add to the city. A completely different example is when we start using sensor data and start connecting that. One smaller example is the DHL smart truck. So it works like this. They're actually working together with it's a prototype project in Berlin, and what they're doing, they're working together with a Berlin cab company. So they have built sensors and GPS locators into the cabs. And then from the movement of the cabs, they can see where there are traffic jams. And then they send that data to the system in the trucks and can, in real time, reroute and reschedule the delivery program for each individual truck. So if the truck is planned to actually deliver something there, then he can, but he can't really go there because there's a traffic jam or it would take too long. He can actually reroute around that in real time and deliver that other package first and then go back to there because then the congestion is stopped. Things like that, where we starting to understand that also a big part of that is understanding how we can connect different aspects, different data, different contexts in a city to get new insights. So I think one of the most interesting things about this is that they use data from the cab drivers to reroute the package delivery in the city. Something that I think is pretty new for them. On a much bigger base, one of the most interesting examples of how you could use public data and sensor data is a new project in San Francisco, and it's a typical thing. The problem of not enough available parking space, especially in very popular areas, and San Francisco is suffering from that like I think most other cities. And what they came up with is a new system how to actually balance that out, because they always have more parking space available in not so popular places, and then but no parking space available at all in very public places. How can we balance that out? And how can we make it easier for people to find open parking spaces and to explain that? I let them speak for themselves.
Finding a parking space can be frustrating and time-consuming. It's estimated close to a third of city traffic is caused by drivers circling while looking for a space. Some drivers just give up and double park. This clogs our streets and needlessly pollutes the air. These cars slow down public transit and get in the way of emergency vehicles. And drivers focused on finding parking create a hazard for pedestrians and cyclists. There is a better way. San Francisco is testing new parking technology and a flexible approach to pricing that is designed to make parking work better for everyone. SF Park's goal is to have at least one parking space available per block. That way, drivers can park near a specific destination without the need to circle the block or double park. This also provides a steadier flow of customers for business owners. SF Park provides safer and clearer streets for everyone. Here's how it works. Newly installed parking sensors detect when a parking space is available. Drivers will be able to check parking availability and rates online, by text message, and by smartphone before heading to their destination. This will help people decide whether to drive, take public transit, bike, or walk. When people choose to drive, new SF Park meters will make paying easier. In addition to taking coins, the new meters will accept credit cards and SFMTA parking cards. Parking time limits will be extended. Easier payment and extended time limits will help drivers avoid tickets. Prices at city-owned parking garages will be adjusted to provide an attractive alternative to meter parking. Parking rates will be adjusted based on demand, once a month, never by more than 50 cents. So, in areas where it seems nearly impossible to find a parking space, rates will increase until at least one space is available most of the time. And in areas where open parking spaces are plentiful, rates will decrease until most of the empty spaces fill, or until rates bottom out at as little as 25 cents per hour. SF Park is designed to ensure that drivers easily find an open space near their destination. SF Park will help people plan ahead, making informed decisions about the best time and the best way to visit busy areas. SF Park begins its federally funded pilot project in 8 areas across San Francisco, starting in the summer of 2010. Use sfpark.org to learn more. Sign up for project alerts and to let us know what you think. Circle less, live more.
I don't know if it's actually going to work out, if it will work with the behavior of drivers in San Francisco, but I think it's a very interesting approach to the problem of parking space, and especially this combination of a few different aspects. It's not only that I can see on my smartphone where is the next, or in that area where is an available parking space. Also this adaptation based on adaptation of the price based on how much space there is available or not available to balance that out a bit more. And I think it's really interesting then to observe how people actually use it. Will they go online before and see, oh, there's actually quite a few parking spaces available where I want to go, so I'm taking the car, or there's nothing available anymore, so I'm taking the bike or taking the bus or something like that. I think it's a very good example, especially like what you could do if you start using sensors and then using the data from that, and then to bring it back together with the phones or the devices that we use in our city life. And I think these are just a few examples of something that we love to refer to, this concept of the city as a platform. And I think all the things we talked about today with how we use big data and how what we can do with that. I think this is one of the most interesting contexts of actually applying a lot of that. And there's so much available and so much possibility there. And if we start to think of the city as a platform where we can build on top of the things that are available, and we can offer new services, and it could be really simple stuff like the Foursquare health service that actually I think was built in a hackathon on a weekend, because everything that you needed was already available. You just needed someone to bring it together and make it available. So when we think about that, the city as a platform, there's a few questions that always come up and that I think is really important to discuss, because we're now at a place where the data is available, that sensors are available, so there's a lot of ways to track and to gather data. And now there are a few follow-up challenges that I think is really important to address, and it's not only in the context of data in the city, but also in a lot of other contexts where data is used. And the first one is also what Stefan said, is the question of how do I actually visualize that data? And I think this is one of the very important points about that, because there is tons of data available, but the question, which of the data am I showing and how am I showing it, is super, super important. Because that actually, for example, in an example like SF Park, how I visualize where there is available free parking space influences the daily lives of people. Not only because it's easier to find something, but because it how I visualize actually helps them make, or will influence how they make decisions. So does it look very crowded? Then I might not go there, even if there is available parking space. But if I choose a different visualization, I can actually, with the same data, get them to a completely different decision. And that's something that especially designers have to keep in mind. There's a new responsibility of how I actually display the data and what I do with that. And one thing, and this whole thing of data in a city context, the usual buzzword is called smart cities. I don't really like to use that because it's very much used by a few big corporations like IBM and Cisco and Siemens. And I have a problem with most of their approaches, and that is that they like to use the data that citizens produce, but they're really bad in giving back. And I think that's one of the major challenges that we face when we talk about using data in a city context is, do we only want to be the ones to produce the data, and then companies like Cisco and IBM come in and do something with that and give it to the city government or to big corporations? Or do we actually say, if you want our data, we want something back? And what we actually would prefer is that you give us the data back so that we can use it too. Or whatever you do with that, give us that data back so that we can use these things. There's especially around here in Berlin, when you use like the public transport apps on the iPhone, they all are based on access to public data. So if you use like Far Info Berlin, Yeah, it's based on the possibility to access the data of the public transport. If we don't have that, if we don't have the possibility, then then we can't have this really good the really good applications. And that's a problem. There's cities like New York are really on the forefront of that. New York said, we have all this data, but we're not really good at programming. We're not really good at developing applications. So what we're actually going to do is make all that data available, and then we're going to have a big contest where you can win, I think, around about 50,000 K or something like that, and just to honor whoever comes up with the best application to make use of their data. And I think that is a really good example of a city who gets what it's good at and what it should give to others because they're better at it. So I think open data is a really big point, and the question of ownership. Who actually owns that data? When I'm, for example, when I'm using Foursquare, yeah, and I'm giving data there, I'm giving my check-ins. Who owns that? Who is allowed to use that? And I think, especially when I'm not really sure what data of me is gathered, and, especially with sensor data, like data with SF Park, the sensor data that is tracked there. Who owns that? Who has access to that data? Should it be something that belongs to the citizens, because the citizens actually produce that data? So these questions of how do we visualize the data, how do we make it accessible, and who owns it, who can do what with that, I think are very key to get to the next level of what's possible with data in the city. Thanks a lot.
Any questions? Questions about how to visualize the way to the toilet today?
Did somebody check in on the toilet?
Did somebody check in on the toilet? I actually saw on Twitter that a lot of good talks today happened in the queue before the toilet, so yeah, it's not that bad. So next time we really need to graph it somewhere. What I really find interesting, and that's really difficult also with this San Francisco example, is really this question of how do I make it visible in that point in time. I'm driving a car right now, you know, it's just like I'm driving a car in San Francisco where 10 million other cars are driving around at the same time, and I think that's a really big issue now. If we want to, how do I visualize real-time data at a given place so that I can access it right now when I drive past. So these kind of things. So it's such a short time, highly geolocated, and I'm in action. So do you have, are there any answers out there? Maybe Stefan can tell us as well. I know. But that's a really important question.
It is, and if you look up the like articles on SF Park, it's always the first topic. It's like, no, they're not circling around the corner, they're looking on their iPhones and looking like, where's the next thing? I mean, that's definitely one of the biggest challenges for them. And I think there are different aspects of that. And that's why this is an experiment. They want to find out, does it actually work? I think there are different levels of behavior. So, for example, it might just be that my first step is while I'm at home planning my trip today, I go on the website and see, okay, that area over there already, every parking space already is gone. I should not even think about getting there, or there's a lot of it available, so I can definitely go over there. So there's, and then when I'm there, then I'm looking for actually the next free parking space, and then what they say is, please drive over and stop and then look at your phone. I'm not sure how that works in everyday life, but that's the stuff that they're learning. So they actually, just by observing how people use their system, again, seeing the data that's created from people using the system, they will gain the insights to actually learn and then iterate on that. And I think that's, the interesting thing with a digital, almost a post-digital thing where you have like sensors that then get something into the digital realm, it's so much easier to iterate pretty fast and then and adapt to how people actually use that tool, use that system, and then apply to it. But definitely that's one of the big challenges. I mean, it's also the big challenge that, like I joked at the beginning, that we all know the walk like this to a city, and everything that's connected to that, for sure.
Yeah, but I think that's a good endpoint of our talks, because we talked a lot about the unknowns, about data which we don't know about, because it's too big, it's not structured, it's maybe not open, it's not easily accessible, we don't know how to display it in real time to really make it usable, all that, so we just need to try and find out. So I think that's a matter of how we need to work, just come up with an idea, see if it works, do some prototyping, learn from it, gather data about it, maybe learn from it, go back and try to find a new idea or go on with the idea and all of this. And I think that's a very interesting point, because it combines everything we talked about today. So I can stand up and wrap it up a bit. So thanks again. I think that was great. So what do you, if there are any other